So this ends up being the final embodiment of that panel itself, this being a DML used inside. There's two of these in each of the PL12 products manufactured by Tectonic and used for live sound. And a couple of interesting characteristics. Did I just pop it? A couple interesting characteristics about this particular panel when we started working on it. My input relative to this project was in the sense of that I wanted high sensitivity. I was mostly working with the company in terms of giving them some understanding of some of the requirements of the environment they were walking into, where you have very high SPL levels. So typically we try to resolve that high SPL requirement with making products that have very high sensitivity so that we can deal with the duty cycle.
Yeah.
So average power, peak power, all those issues that a typical loudspeaker confronts when it's hung 40 feet in the air and people are standing 30 meters away. Well, a pair of these is giving us, we said 104?
Yep, approximately.
104 dB, 1 watt, 1 meter, which was, to me, astonishing. I never believed that we could get that much SPL. Some of the other things that we found when we were going inside in the chamber making measurements was, to me, I actually had to go send my Clio coming back to Italy to get calibrated because I was measuring distortion so low when it came to odd harmonics that it didn't jive with, I thought my microphones were bad. I thought the Clio wasn't working correctly. But in fact, it actually was the panel that generates extremely low odd harmonic signatures. And so we're talking, at 93 dB of measured audio level, and using an AES standard, we're measuring below 20 dB of noise being generated by the actual device.
Wow.
So this actually translates positively well into a live sound environment because you don't hear any error. Another thing that was fascinating to me was the phase response of the product itself.
Yep.
And even when hanging multiples, we're measuring flat phase response all the way through its operating band. So you don't see the phase flip until you get up to 17 kilohertz.
Yep.
And it's completely in phase. So when you can actually control the phase characteristics and that critical intelligibility area of 800 hertz to 8K, you're way ahead of the game. Everybody else has got to deal with crossovers and equalization and multiple horns right in the middle of that 2 to 4 or 1 to 4K region, which is critically important for people to be able to understand what's happening, let alone have a musical experience. So, yeah, it's quite fascinating. It certainly is kind of flip my opinion about what this technology can do and where it can be applied effectively.